There comes a time when we heed a certain call, when the world must come together as one. There are people dying.
When it's time to lend a hand to life, the greatest gift of all.
We can't go on pretending day by day
that someone somehow will soon make a change.
We are all a part of God's great big family, and it's true, you know, love is all we need.
We are the world, we are the children, we are the ones who make a brighter day, so let's start giving.
There's a choice we're making. We're saving our own lives. It's true, we'll make a better day, just you and me. Well, set up your heart, oh, so they know that someone cares.
So their cries for help will not be in vain.
We can't let them suffer. No, we cannot turn away.
Right now,
Please, the last announcement for today. My boss said they will fire me if I don't do this tomorrow. Please, I've been told you are not posting cry, you are not tagging us, which is very bad. Please, let's take some selfie and post and tag Ghana Data Science Summit. Please, I beg. The hashtag is GDSS 2024. Hashtag IndabaX Ghana 2024. The IG and the X handle is at GH Data Science. LinkedIn is Ghana Data Science Summit. Please, if you don't want me to eat this evening, then you don't do it, okay, please. But if you want me to eat, please do that for us. You can also see the emergency hotlines. Keep it for tomorrow and the third day. Please, let's start coming in now. Our time is up. We have just 2 lightning sessions, 50 minutes each. Then we are done. Please, let's come in. Oh, let's get settled, please. Please, I beg you. Let's settle. Let's settle, let's settle. So our first lightning session is presented on the theme Efficient Maize, a lightweight data set for maize classification on resource-constrained devices. To do as the honors, help me welcome. Hey, oh, brother, why? Why? Thank you for paying attention. I'll take it again. The first lightning session is on the topic Efficient Maize, a lightweight data set for maize classification on resource-constrained devices. And to do us the honors, let us give it up for Mr. Imadi. You can do it better. Keep clapping till he gets here, please. Show him some love. Thank you.
Good evening. And then I was coming to say, permit me to stand on the existing protocols. But interestingly, the protocols were established in the morning. But still permit me to stand on the existing protocols. First of all, I would like to thank the organizers for giving me this opportunity to share what we are doing in our own corners. And then I was happy to have met so many people here. I was quite surprised. Last year, December, I was with Professor Ponyo in the New Orleans on such a similar occasion. And I was so glad when I met him here again. I'm hoping that I'll see him again very soon, somewhere. And then I'm seeing plenty students from the University of Energy and Natural Resources, where I had my BSc in Computer Science and MPhil in Computer Science, where I'm also currently pursuing my PhD in Computer Science. So during my MPhil thesis, I was wondering what I could do to benefit society. In fact, the decision to pursue computer science always revolved around that. And I kept asking myself, how can I impact society with the computer science that I'm doing? Because you build an app and there is an old woman in the village who doesn't know how to use an application. So how are you impacting it in terms of inclusivity, which has been the theme throughout since morning? And then I realized that in the year 2021, Ghana Statistical Service, in the course of the presentation, I'll call it GSS, established from the population and housing census that more than 53.3% of the employed population, that is 15 years and older, are in the service sector, followed by agriculture, which is 33%, with the industry having at least 13.7%. And we all want to run into the industry. And in the morning, we have established that agriculture is actually the wheel of most economies. And in fact, Ghana is not an exception. Data from Statista in 2022 shows that 19.57% of the GDP contribution was actually from the agriculture sector. And I believe that with the application of AI, we can double, triple these numbers, and then our economy will grow. So if Ghana really wants to grow, then we have to digitalize our processes. And I'm glad that Madam just left the stage telling us how we can actually achieve that in so many ways. And this is how we contribute to that in small fraction. So maize is a staple crop produced and consumed by most farming households in Ghana, according to the Ministry of Food and Agriculture. So maize is what most of the Ghanaian households consume daily. And then you can all bear witness with me. If you can't, then let me take you through the process that maize production goes through in Ghana, at least per my interaction with Heritage Seeds, the seed company that I undertook this research with. We start with planting, which will grow and then it will dry, we harvest it, and then we give it to a peeling machine, which will take off the leaves. Technically, it peels it off, then it gives it to the dehusker, which remove the corns from the maize, whatever. This device has holes beneath it that does the sorting. So the mazes that are bigger will go into the first hole, the stones will go into another one, and then the product also has an end that it passes through. When it comes out like this, then they employ market women or women who are experts in maize sorting and classification. Then these women will then use their hands, their eyes, to group the maize into good and bad seeds. And then they will package it to the market, and then we'll buy these ones and consume, or better still, go and plant again. Now, this is where the problem is. If one woman is tired and has worked throughout the day and is sorting the maize to come to the market for us to go and buy and consume, or probably harvest again, then there is a probability that he will be missing the good seeds with the bad seeds. And as young data scientists, machine learning experts, what can we do? We can find a way to eliminate this process from the cycle so that just at the end of this machine, we can have some controllers which will be able to group the maize according to the quality or according to the viable stature, so that by the time it comes out, it is already sorted, in a sense that we don't need any market women or women of experts to come and do the sorting again. And that is not to say that I'm taking their job away. They will take it and go and sell it. All right, so on that note, we realize that accurate classification and recognition of the varieties of maize are crucial for the Ghana's agricultural productivity and food security. I've already mentioned the problems that are associated with the traditional methods, and there are some advancements in machine learning that are already doing this in other countries. But then we realized that it was said in the morning, and when Santiago was doing his presentation, if you listen to him carefully, he said the AI model that they are using to do the weather forecasting has just 1 million parameters. And I'm saying just because if you are using VGG, then you realize that you are talking about 136 million parameters. And you can't implement such models on resource-constrained devices. And the best means is to define your own model. And that is what we try to do in this research. So the goal was to compile the maize seeds, the variety of the maize seeds that are commonly grown in Ghana. And then we were to define a small CNN classifier to test whatever that we have compiled. And then there are some pre-trained models that are actually mobile compatible, like the MobileNet. It was developed by Google researchers. It has some few parameters, and then you can actually implement it on resource-constrained devices. You have efficient net. It starts from B0 up to B7. This is also mobile compatible. So we try to compare whatever that we have defined to these advanced technologies, AI models that people believe and trust in. It is not that difficult. Madam said she doesn't want to hear the fact that there is no data available. Yeah, data is available, but the data set is not available. All right, yeah. So when I decided to embark on this journey, I searched on electronic databases, Mendeley data, Kaggle, and I realized that you can't find data sets of maize in such formats that are of single seeds. There is a maize data set on Kaggle, which has a red background. You can search right now, but it's taken on an A4 sheet with the seeds lying on it. So just as she said, if you want to really take it and process it, then you would have to take it and crop the seeds out of the A4 sheet one after the other. So this was a contribution. And this is how we went about the data collection. We realized hyperspectral imaging also contributes to the size of the data set because it collects plenty details, HSI images, and you can't use this to build lightweight models. We had to go through the traditional approach because we just want to take a picture of the maize and be able to tell whether it is viable or not. That is basically what we want to do. So we employed traditional means to capture the images. And of course, we didn't have labs that we could do this research. So we set up a lab in our offices, in front of our offices, with just a flat edge table and an A4 sheet, of course. And then what we do is that we lay the seeds of the maize on it like that. Then with a 12 megapixel phone camera, we capture it in this setup. There was no technical details. We use autofocus of the phone to make sure that the images are sharp so that we can capture them. And after this, we separate the images according to the seed quality, of course, with the help of the experts from Heritage Seeds. And then we save the annotated images to their respective folders. And then we pre-process the images by cropping, resizing, cleaning, And after that, we reconfirm whether the classes that we have at the end of the day is correct. Of course, with the help of the experts once again. And at the end of the day, we save it in their respective folders. So this was the initial setup images when we put the seats on the A4 sheet. Don't worry about the blue background. We just wanted to capture the images with clarity, and then a white background and the sun rays. If you look at this setup, we collected it during daytime. During the daytime with daylight. So of course, there was no lighting condition as well, taking into consideration just the daylight. And this is what we had at the end of the day. And we defined a tool because we couldn't crop the seats out of the A4 sheets one after the other. So we defined a tool that we use to crop the images. And in fact, it was very helpful. It's available that you can email, and then maybe we will be able to get it to you, then you'll be able to use it for such tasks. Because if you want to get a tool that will crop images from one single picture at a time, you realize that it's difficult finding such tool. You may have to crop it one at a time. So at the end of the day, we had samples of the good data sets, and then we had samples of the bad seed data sets as well. And all these things were gathered with just 3 varieties of maize. Of course, it was an experimental data set that we were doing. We have a bigger picture, which we are trying to implement in this PhD thesis. So of course, we are going around collecting data sets of seeds of the commonly consumed food products in Ghana. So we defined a small machine learning model that was used to classify. Google used 1 million parameters, and then I used 429.25 kilobytes of parameters. Yes, it was very small because we want to implement this on a mobile phone and for it to run seamlessly without even you realizing that there is an AI model behind the scene. So 429 kilobytes memory was used. Forgive me for the bad graphics. I can't even see from here. So of course, the algorithm that we defined was able to perform better because we had access to customized things to suit the specific classification task that we are doing. The mobile net, the others are trained on the ImageNet data set, and it has a lot of features that if you really want to get the best out of it, you have to freeze the base layers, train it on your images to be able to get something out of it, fine-tune it in some ways. So at the end of the day, we were able to achieve 91% accuracy with a distinction as compared to MobileNet, which gave us 88, and then EfficientNet. You really have to fine-tune it. It's not like it's not performing. You see, the accuracy it's giving us is 0.54, like 54%, very bad. But MobileNet is really good. But then the fine-tuning process is hard, and we don't have time to be waste 2 hours, 3 hours, just fine-tuning one model. So we included it in the results, and then I remember when I was presenting this in the New Orleans, the guy who actually defined EfficientNet came close to my research, and they were laughing at it. And they actually acknowledged that, of course, there are some researchers that are complaining that you have to really fine-tune EfficientNet to be able to get the best out of it. So at the end of the day, we were able to classify the maize 6.14 times faster than EfficientNet, and approximately 3.7 times faster than the MobileNet. But in a nutshell, what are we really doing? Just as I said, we want to come up with a tool that will benefit Ghanaian farmers. We want them to be able to make seamless decisions in real time, whether to be able to buy seed and plant, whether the seed they are buying is going to give them good yield. And that is the purpose of this tool. Thank you so much. And of course, the data set is available at Mendeley Data and Kaggle as well. Please go there and play with it, perform some modeling with it, and let's see the results so that we can achieve greatness together.
Thank you, thank you, thank you. Please go and search for it. Those of us who like Benku, my bishop said Benku, go and search for the data too. All right, our final and last presentation, also a lightning talk. Yeah. Okay, so the last one is on Ghanaian Sign Language Image Detection using Capsule Network. Please help me welcome Mr. Yusuf El Alawa. Oh, you can do it better. Please keep clapping till he gets here. It's a lightning one, so 50 minutes, then we'll be out of here. Thank you.
So my name is Yusuf once again. Ladies and gentlemen, I'm to talk about Ghanaian Sign Language image detection using Capsule Network. This project was presented last year by me and my supervisor. And it's an amazing project because in Ghana here, sign language is a very difficult task to talk about because sign language, we've gone through so many ways to get data set for this language, but we have struggled a lot. Yeah. So the research, sign language recognition has been going on since late 90s. Yeah. As you know, communication is a vital human right. Yeah. So you know the deaf and the hard hearing society, they are neglected by we. So they don't. They feel neglected, and they are unable to experience how sign language works. Yeah. So it serves as the critical communication tool for the deaf community, with estimated 5,000 to 2 million users worldwide. So in India, millions of deaf individuals exist. Up to 90% of deaf children born with hearing parents who may lack efficiency in sign language. So we come to the methodology. Due to our best of knowledge, we are unable to get data sets. Yeah. So we took data sets from teachers, lecturers, and people around campus. First of all, I'm from the University of Energy and Natural Resources. Yeah. We took 7,200 images, and it was splashed into 2,004 numerals images. That's from 0 to 9, and 5,200 alphabet images from A to Z. Yeah. And these images were collected by 210 volunteers. Yeah. As I said, the lecturers and the students. Yeah. So although convolutional neural network has been prominent in deep learning detection, but we decided to go with capsule network. Yeah. When I say capsule network is a neural network architecture which is best for handling hierarchical features and spatial relationships. So when I say hierarchical features, I mean in order, hierarchy. And the spatial relation, I mean how the image is being detected. Yeah. So this study adopted and designed a capsule network called Sign Capsule Network. So the deep learning model for the sign language using Ghanaian Sign Language dataset. So this is the flow of my methodology. The created dataset was split into two for training and texting. So it was split into 70% and 30% for training purposes and testing. So the model performance was merits such as accuracy, precision, and recall and sensitivity used. So with a curated data set, the data set went through image processing. And with the image processing, we are able to make sure that we're able to take let's say this for example, the shape of this image, yeah. You make sure that you're able to take the data set just like this image, yeah. And we went through data splitting, yeah. With the data splitting, we split the data into, let's say, A, B, C, D, up to Z. Yeah, so we split it into folders, yeah. And we prepared the data set for training purposes and testing. And from there, after training and testing, we had our interface. Just like we are classifying the image we had. Let's say I have a sign like A. So with the A, it's going to bring an alphabet A. That's what I'm trying to say. So this is the sample Ghanaian Sign Language image data set. So the A stands for the alphabet data set and B stands for the numeral data set. Yeah. So this data set was taken in different shapes because we cannot get a perfect data set, as you know. Yeah, due to our knowledge, there wasn't data set available online. So we decided to take our own data set, as I said earlier. So this is the sign capsule net model. With the sign capsule net model, it's made up of 3 layers. The convolutional layers and the primary capsule layers and the sign capsule layer. So the input image, let's say A, goes through the blocks, block 1, convolutional 1, and block 1, convolutional 2, block 3, convolutional 3, It goes through, from there it goes to the primary capsule layer. Yeah, and from there it comes to the capsule layer. Yeah, as I said, the convolutional layers are used for feature extraction. So the feature extraction, it takes the image, the shape of the image. Let's say the edges of the image that we take. Let's say the edges of this. Yeah, it's to make sure that it takes it, just to get the right image. And it goes through the process. And the feature extracted from the layers are forwarded to the primary capsule layers to determine other important features in the image. The feature from the primary capsule is then forwarded to the capsule, the sign capsule for prediction. Yeah, that's the classification. We come to the results. The results is the model, the original capsule net is the one that was available already. The capsule network was derived or was created in 2017 by Geoffrey Hilton. Yeah. So this was the original capsule net. So I compared the original capsule net with the sign capsule net. Yeah. So I got 97.0, and the original capsule net was 83.0. The precision was 82.2, and the precision for mine was 98.0. The recall was 84.1, and mine was 97.0. So sensitivity was 84.1, and mine was 97.8. Yeah. This graph represents the training and validation. I know you can't see, sorry. It's made up of red and orange, and green and red, and orange and I think violet is ours. But I'll talk about the red and the green. So the green it represents the training accuracy, and the red represents the validation accuracy. Yeah. So these two, this is for the accuracy and this is for the loss. Sorry. And so the green, the model is learning from the training data. Yeah. And the red, with the red, the model is generating new and unseen data. Yeah. So let's come to the training and validation laws. With the training and validation laws, the green the green curve also represents loss values which has a better performance, and the red curve, yeah, but that one is having it's similar to the accuracy for the validation. It's very similar, just that is avoid overfitting. Yeah. This is the virtual representation of the model. So sample heat map from the model. So the heat map visualizes areas of focus in the image where the model assigns higher importance during detection. Yeah. So as you can see, T sign, U sign, K sign, O sign, yeah. So this is the virtual representation. So the discussion and future works. Can I continue? Okay, the time is up. Okay, discussion and future works. The study demonstrates that the deep learning holds significant purpose for Ghanaians for image detection. Despite the small evaluation data set, the proposed method achieved a high accuracy of 96%. It suggests that even with the limited data, capsule networks can effectively recognize Ghanaian sign language signs. The model shows potential for creating applications to assess the deaf communities in Ghana. Although the model performs better in sign language, however, accuracy may vary with different data sets to wider the range of signs. So high accuracy of the proposed system indicates the deep learning networks can effectively train to detect sign language, even with the limited data, which could lead to beneficial applications for deep population in Ghana. So, thank you. So I can conclude that we created alphabet A to Z and numeral values 0 to 9 with deep learning capsule network, sign caps to design and implemented in detection of Ghanaian sign language. Yeah. So we had an accuracy of 97%.
All right. Thank you very much. Thank you very much, Yusuf. Thank you, Yusuf. Myself, I have some translated really admire. I hope this goes far so that they'll all make good use of it. Please take note of the following announcements as we take the closing remarks. Please, let's take notes. The check-in starts at 7 a.m. 7:30 a.m. It's not like you are leaving your house at 7:30 a.m. No, not that one. We want GMT, not Ghana man time, please. So be here on time and let's be seated before 9 a.m. Also, tomorrow is going to be full of hands-on tutorials, workshops, demos. Please bring your gadgets like I said earlier. But make sure to remember that we are not one. If your gadget is missing, I can't find it for you. Okay? Hello, somebody. Hello, somebody. I can see some people looking for their gadgets. Please, it's there. Don't worry, it's not missing. Let's also take notes that the first sessions will be done here and we'll move to our workshop venues. So let's come early so that we get where we are going. Are we good? Are we good? I welcome our founder, Mr. Delali Agbayega, to give us the closing remarks. Please give that for him.
Hello? Hello? Okay, can you hear me? Okay. All right. Thank you all for staying with us. It's been a very long day, and I think some people have already left, but I hope you all got something out of the sessions. Once again, we truly appreciate your time here. Tomorrow is going to be another interesting day. But before I talk about tomorrow, what will you say is the theme for today's talks? What have you learned? You can just shout it. Shout something. Data, okay, that's good, because we realize that everything has to start with data. All the presentations, almost all of them said you need good data for you to get good output. So data is one. What else? You can shout it. Responsible. So we must build AI systems that are responsible. What else? Machine learning or ML. All right. Okay. This is great. So tomorrow we are continuing with our sessions, and in the morning we will have 2 sessions here. So please, let's be on time. Check-in here starts at 7:30 a.m. We'd like to have all of you seated by 8 a.m. We'll have 2 keynotes tomorrow. And then from there, we will all be bused to the business school where we'll have our hands-on sessions. But even before that, we'll group picture. So right after the second talk tomorrow, please, our ushers will help us and put us together for a nice, very good group picture. So if you have the T-shirt, please feel free to put yours on again tomorrow. Even if you are wearing it today, we can do wash and wear, right? Can we? Anyway, we also have the T-shirts on sale. So if you are not an organizer and so you don't have one, we have some on sale. I think it's going for 75 cedis. So please buy one and help us spread the vision to drive awareness of machine learning and AI in Ghana and beyond, as well as build capacity in AI and machine learning. And so with that, I will say thank you, and we will see you all tomorrow, God willing.
Please, Yapon. Time for taking pictures, posting, tagging, and all other things. Miss Hilda is still here, all the way from Kenya. Please interact. The job she talked about. Please, I want to see you working with her next year. I beg you. So let's get all the connections, make new friends, talk to somebody, sit with them tomorrow. Please, photographers, so you can come for free shoots. Please, you can get photo shoots after showing proof that you followed and tagged us. Please, offer lasts in 10 minutes. You subscribe, he takes you. You tag us, he takes a picture. You can even use it for your LinkedIn profile picture. This is the best time for you to get another picture. Please come. Follow us, Ghana Data Science, Kwekutech Ghana, hashtag Indaba 2024, Ghana 2024. Come and take your LinkedIn profile pictures here. If you have not tagged us, you will not take it. If you've not followed us on LinkedIn or Twitter or IG, we will not take it. Come and show us proof. Show me proof first. I want to see that you have followed us. No. Ghana Data Science. Show me the proof for Ghana Data.